Okay, now let's do the 8th question. Here in the question it is said that consider an LTI system whose input x of n and output y of n are related by the difference equation, which is y of n equal to 1 by 4 into y of n minus 1 plus x of n. If x of n equal to del of n minus 1, then y of n is, we have to find out our y of n. Okay, for that I am just going to find out the z transform. So this will become y of z equal to 1 by 4 into, this will be z raised to minus 1 y of z plus x of z. So instead of x of z, it will be equal to z raised to minus 1 only. So I am going to write z raised to minus 1. From here I can get y of z equal to 4 into z raised to minus 1 divided by from here I'll get y of z minus 1 by 4. I'm simplifying it into y of z equal to z raised to minus 1. From here y of z equal to z raised to minus 1 divided by 1 minus 1 by 4 into z raised to minus 1. Right. So that is equal to y of z equal to 1 by z 1 minus 1 by 4z. From here we'll get 1 by z 4z minus 1 divided by 4z, that is equal to y of z divided by 1 divided by z minus 1 by 4. Okay, from here instead of 1 I am going to write z into z raised to minus 1. Okay, then only we'll get the standard form of z transform. Now to find out the inverse z transform, what is the which value gives an z transform of z divided by z raised to z minus 1 by 4, we'll get a raised to n u of n. Okay, so that will be equal to 1 by 4 the whole raised to n u of n into z raised to minus 1. It is multiplied by z raised to minus 1. So when does this z raised to minus 1 come in an z transform is when there is a time shift. So that will be shifted by 1. Okay, so the answer will be equal to 1 by 4 in raised to minus 1 u of n minus 1. Okay, so that is Okay, now let's do the 13th question. In the 13th question, it is an LTI system with the input x of n and output y of n. And y of n, the equation is given here, y of n and x of n, where a is a real and less than 1 in magnitude, and x of n is having 0.5 raised to n u of n. The value of the constant b for the system to be an all pass with unity magnitude responses. Okay. So from here I'm going to take the z transform over here. So it will be y of z equal to, y of z minus a into z raised to minus 1 y of z equal to b into x of z plus z raised to minus 1 x of z, right? And it is been asked that to find out if it is an all pass signal, so we have to write it in the frequency term. So z will be transferred into e raised to j omega. Okay, so our instead of z we are going to write e raised to j omega, which is equal to this a is going to go on the opposite side. Okay, so a into z raised to minus j omega y of e raised to j omega, no, the b here, equal to b into x of e raised to j omega plus e raised to minus j omega x of e raised to j omega, right? From here h of e raised to j omega is actually equal to y of e raised to j omega divided by x of e raised to j omega. Then only we will can find out if it is a null pass signal or not. Okay, so let us find out. Okay. From here, I am going to take y into e raised to j omega outside. We will get 1 minus a into e raised to minus j omega. And the other one is b into b plus e raised to minus j omega into x of e raised to j omega. From here, y of e raised to j omega divided by x of e raised to j omega will be equal to b plus e raised to minus j omega divided by 1 minus e raised to minus j omega. Right, I am going to expand this. So it will be b plus cos omega minus j sin omega whole divided by 1 minus a into again cos omega minus j sin omega. Okay, from here e raised to j omega equal to b plus cos omega. I am going to write all the real terms together. 1 minus a cos omega plus ja sin omega. Okay, just going to take the magnitude. We will get b plus cos omega the whole square plus sin square omega whole divided by 1 minus a cos omega the whole square plus a square sin square omega, which is equal to b square plus 2b cos omega plus cos square omega plus sin square omega whole divided by 1 minus 2a cos omega plus cos square omega plus sin square omega. We will get b square plus 2b cos omega. So this will be equal to 1, right? Divided by 1 minus 2a cos omega plus 1. Okay. In this, okay, this was a square, right? I'm sorry. Okay. From here, this is the square of a magnitude, right? For an all-pass filter, it should pass all the frequencies equally. That means that the magnitude should be equal to 1 no matter what the frequency is given into the filter. Okay, so we have to find out the value of a and b so that this fraction will be equal to 1. Okay, so if b is equal to minus a, see what happens? A square minus 2b cos omega plus 1, right, divided by denominator it is 1 minus 2a. Instead of b I am going to write minus a, right? Okay, 2a cos omega plus a square. So we will get 1. So the value of b for this system to be an all-pass filter is equal to minus a. B should be equal to minus a. That's the answer. Okay. Now let's move on to the next question. In the 14th question, it is given that y of n minus a into y of n equal to b into x of n plus x of n minus 1. Okay. The same question equal to here it is already given a equal to minus 0.5 and has poles P1 and P2 and zeros Z1 and Z2. The value of P1, P2, Z1 and Z2 we have to find out. Okay. For that we are going to do our Z transform. So from here y of Z equal to y of n minus a into z raised to minus 1 y of Z equal to b into x of Z plus z raised to minus 1 x of Z. From here y of Z x of Z is actually equal to Z divided by Z minus 0.5. Okay. So y of z equal to, instead of x of z, we are going to write b plus z raised to minus 1 into z divided by z minus 0.5. And y of z, this will come downwards, that is 1 minus a into z raised minus 1. Okay. It is already given in the question that a is equal to 0.5, right? And for it to be an all pass filter, we have already find out b should be equal to minus a. So I am going to substitute that over here. We will get z raised to minus 1. Instead of a b, we are going to write minus a, where a is 0.5. A is equal to minus 0.5. So it will be divided by 1 plus a into, that is 0.5 into z raised to minus 1 into z divided by z minus 0.5. Okay. And we have to write that in such a way that we'll get in the pole 0 format. Okay. So for that I am going to write z raised to minus 1 as 1 by z plus, and take the LCM, we'll get 1 divided by 0.5 z and z plus 0.5 into z minus 0.5 into z. Okay. Now for poles which is on the, sorry, if zeros are on the top, for zeros it will be z1 equal to 0 and z2 equal to minus 1 divided by 0.5, right, which is equal to minus 2, and p1, which is our denominator, which is p1 equal to minus 0.5 and p2 equal to 0.5. Okay, so that is the answer for the 14th question. Now let's do the next question. Question, a causal LTI system with the input and output is given here, and we have to find out the initial value of y of n. So from the previous answer we know that y of z equal to 1 plus 0.5 z divided by z minus 0.5 into z divided by z plus 0.5, right? So initial value theorem, where limit n tends to infinity, sorry, n tends to 0, y of n equal to limit z tends to infinity, y of z, right? So y of z, sorry, limit n tends to 0, y of n equal to limit z tends to infinity, 1 plus 0.5 z divided by z minus 0.5 into z divided by z plus 0.5. Now we'll have to simplify this. I'll take z outside. From numerator and denominator we'll get 1 by z plus 0.5 divided by, here also it will be 1 minus 0.5 by z. Here also we'll take z outside, we'll get 1 divided by 1 plus 0.5 divided by z. Now applying the limits, we'll get answer which is equal to